but I couldn't do it without kind of parsing the whole program, or even I couldn't even parse like a single file. And so then I ended up going to this it was a Slack or a Gitter channel. I don't quite remember. And I asked them, can I like change this one piece just like without doing anything super complex, And the response was kind of like, well, why would you want to do that?
Machines are so fast and stores are so big that they give us plenty of latitude to screw things up.
The shell, or which is the name we give to the command interpreter.
So the operator got a pair of tweezers and very carefully fished them off out of the relay.
Because you've all read The Mythical Man Month.
And the best motivator in the world for programming is scratching your own itch.
Developers, 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 developers.
Hello and welcome to another edition of the SourceGraph podcast. Today I'm chatting with Renard Van Tonder, creator of Comby, a pattern matching syntax and command line tool which offers a more expressive and more user-friendly alternative to regular expressions for many common patterns in code. We also chat about the research Renard conducted while a PhD student at Carnegie Mellon University, the state-of-the-art of static analysis and automated bug fixing, and what place machine learning has in the world of developer tools. Stay tuned. All right, I'm here with Renard Van Tonder, an engineer at SourceGraph who created the Comby pattern matching syntax, which is kind of an alternative to regular expressions, but much easier to use and kind of designed and optimized for use in code. Renard, welcome to the show.
Hi, Pyong. Yeah, thanks for having me on.
So I guess before we dive into all the technical stuff, I thought it'd be interesting to go over kind of like the backstory of how we met each other. Do you remember how we first met?
Yeah, so I think you might have to fill in some gaps here. I remember my side of things. Basically, I was in grad school at CMU and working on research problems, taking classes, but at the same time, curious to kind of explore other things as you do in grad school. So at one point, I SourceGraph came up on my radar, and I kind of I started playing with it. I thought, code search, this is cool, but also it's kind of poking at security holes, trying to find some fun things. There wasn't much. I think the basic stuff was covered, but at some point I found like you could have like an information leak for public and private repos, and that's when I reached out. And I think you were the person who replied to that email, I think.
Yeah, I think you sent it to security at SourceGraph, which is our kind of catch-all for any sort of security bug report. And yeah, I did reply to that.
Yeah, and I think that kicked off like, do you want to talk about what SourceGraph does? Do you have any feedback about the product and so on? And I remember hopping on a call with a couple of folks back then. And I thought it was interesting. You're tackling kind of a hard problem that there's a bit of a gap, right? The reason I came across SourceGraph is kind of code search that works a little bit more ubiquitously than anything else out there. So
yeah, I remember that because I remember looking you up when you reported the bug, because it was a very nice bug report. It was for like an issue that was indeed an issue, and it was like well kind of described, and it was a good report. And so I looked you up and saw that you did research into software engineering, developer tools, static analysis, like that kind of general area. And afterwards, we kind of struck up we were kind of like email buddies for a while. And then I think at some point you came out to California because you were doing an internship at Facebook or something like that, and you dropped by the office.
Yeah, that's right. That was a couple of years after. I think that was at least 2 years after we had the like email exchange. And I was just there, and I was like, oh, I remember that company, SourceGraph, so I'm gonna go pay a visit. At the time, I think SourceGraph was doing a lot of things in the LSP space, right? So language server protocol stuff, and I was also like becoming more aware of those efforts, and so that kind of tied into some of the things that that I ended up working on during a Facebook internship there. Working on like Python and kind of surfacing, Python related code intelligence or code editor functionality. So, yeah.
Yeah, it's all, at least from my point of view, it was all very serendipitous, and I knew very early on that I would love to work with you someday, and just so happy that you ended up joining the team and bringing all your thoughts and insights into what's on the research frontier to what we're doing at SourceGraph, because I think there's a lot of interesting kind of product features and capabilities that can be built on top of that, which, I suspect we'll get into over the course of this conversation.
Yeah. So thinking about it now, right? What I remember as well is kind of like everybody I talked to at SourceGraph were very keen to get feedback, right? On like not just the product or the ideas that SourceGraph was kind of working on, but also just like, what are your thoughts of having, for example, code search or code intelligence that's kind of ubiquitous and these sorts of things. And so there was never a dead end to a conversation to anyone I've had at SourceGraph. When initially talked, it's always like, what do you think of this? What do you think? And that stood out to me. I think basically identified like a deep desire to kind of go after those goals, go after kind of the things that the company is setting out to do, which is this idea of code search everywhere, code intelligence everywhere, every editor, every interface. And I think it was also a question of I guess mutual interest and really commitment to this idea. So that's why I ended up here.
Awesome. Well, I guess, before we get into research that you've done, and Comby in particular, I always like to kick off the show by asking people how they got into programming originally. So, what was kind of your backstory?
I think I got into my first real kind of programming experience during high school. So my final 2 years in high school, learned to code in Java. I still remember, I think, my first programming experience was looking at a textbook, and there was this program in the textbook, and it's like, copy this, right? Character for character into your editor. And I like type it out. I'm like, I can do this, right? And we're going to run this thing. And I'm like copying. And then after I think I've copied the whole thing in the book, I click run or compile, or it was compile, right? And so this thing just tells me like all these syntax errors happening everywhere. I'm like, what? Like, how did I make this mistake? I looked very carefully at what the book was telling me to do. And it's like, you missed a semicolon, you missed a brace or something. And I was so surprised back then because I was like, wow, it's so easy to make a mistake doing this, right?
Yeah.
So that's one of the first recollections I had doing programming. And from there, it became more interested kind of in understanding, the whole kind of theory around it. Not so much computer theory, but just general ideas like algorithms, data structures, that sort of thing. And then in university, kind of focused in learning more of computer science. I think it was only in university that I kind of got exposed to Linux for the first time, and like becoming like a command line power user and all that sort of thing happened over the course of my varsity years. And I can go into more detail, but that's basically the early beginnings.
Yeah,
for me.
I think that makes sense. Like, it's, I think, a little bit similar to how I got into programming. Like, my first programming language was also Java in that high school environment.
My condolences.
I mean, there are, I think, worst first experiences.
That's true. Yeah, I'm just poking fun.
Yeah. Where along the line of your studies did you decide that you wanted to get a PhD, or was that something that you always felt that you wanted to do?
Definitely not something that I had my heart set on doing. I think my story aligns with a lot of kind of other graduate students or people who end up in academia, at least for computer sciences. You try and shoot for a technical job. Maybe you fail too many technical interviews and you're like, okay, well, I'm going to go to grad school now. I definitely have a couple of data points, of people who've shared that experience, and and to some extent, I am one of them. I think I did a couple of Google interviews and it didn't work out, so I was like, well, not.
Yeah.
But let's try this other avenue, right? Like you send out applications for various things, so I'm like, I'm open to this whole PhD idea.
Yeah.
And I mean, that ended up working out, so I went for it.
Yeah, I got rejected from Facebook myself, so I can definitely sympathize with getting rejected from those big tech companies.
Yeah.
Cool. How did you pick your research area? Was that something that kind of developed over the course of your undergraduate career, or was there some other influence or inspiration?
I decided to focus. Essentially, I went for the reasoning to my mind was I'm only interested in going through a whole research experience or doing academic research if it's a topic that I really care about, right?
Yeah.
Because I mean, all the kind of advice out there is, only do this if you really are committed to the idea, or you're really interested or passionate, if you will.
Yeah.
I don't think that's a prerequisite for going into research, and my perspective on that has changed a bit afterwards. But certainly going in, it was a question of I know that I want to focus on these areas. This is interesting to me. I'm not going to kind of put myself through a lot of pain to learn things that I'm not interested in. So the kind of stuff that stood out to me back then was software security research, but also just automated techniques, automated program analysis for finding bugs, for example. That was the biggest kind of piece of attraction, right? Was can we use tools to automatically find bugs? Bugs and security bugs specifically are super interesting because they have such severe consequences, and it's amazing what ends up happening if you exploit one of these super severe bugs in an important system. And so for me, it was a question of, well, how far can we kind of push automated techniques to find these really complex, really interesting bugs? And from there, it kind of it changed a bit of direction, but that kind of interest has always been there.
Yeah, that makes sense. It's kind of like I guess the general category I put all that under is it's almost like meta programming, like programming stuff, tools that write programs or help you debug programs. Yeah.
There's definitely a lot of, I think, meta to it for sure, and people love kind of throwing that term around. I think meta programming as a term is pretty loaded, so I won't try to put too much definition to that. But I know people who are in the program synthesis community, right? Programs generating programs to do things. This is all also very meta, but also quite different from writing programs to find bugs in other programs, but definitely related.
Yeah. So one of the things that you covered in your PhD research was this new pattern matching syntax called Comby. Can you tell us a bit about what Comby is and what was the motivation for creating it?
So Comby is a tool I wrote that essentially fit the bill for the kind of research problem I was tackling at the time. I didn't really find other tools that could do quite the thing that I wanted out of a code transformation tool. And basically, that came down to I wanted to selectively change parts of a program, parts of program syntax, without having to compile the whole program, without needing to know that the whole program scope or across calls across files or anything like that. Just give me one file, and even if this file contains some malformed syntax or it contains macros or things like this, I didn't need a full compilation or even a full parse of this thing. All I wanted to be able to do was change an if statement, right, or a for loop or things like this. And to make it more concrete, what ended up happening was I wanted to change something in Java and in C. It was a simple if statement, and the conventional way that I would have had to go was find tools that could change particular if statement, matching whatever conditions I was interested in changing in these two separate languages. Now, there are tools out there that can do, you can express a transformation that covers multiple languages. they were a little bit more heavyweight than I was kind of willing to entertain. So I ended up going, can I just find some like simple Java and some simple C thing? Maybe Clang can do this for me in Java, some Java parser thing. So I ended up picking out some Java parser project as well. And then I wanted to change this particular if statement, but I couldn't do it without kind of parsing the whole program, or even I couldn't even parse like a single file. And so then I ended up going to this it was a Slack or a Gitter channel, I don't quite remember, and I asked them, can I like change this one piece just like without doing anything super complex, and the response was kind of like, well, why would you want to do that? Why not just parse the whole thing and do the thing that you want to do? And so I mean, I was like, that's fine, because at the end of the day, these tools are made for particular reasons, and the reason I wanted wasn't kind of aligned with these, right? So I wanted to change these fragments. So Comby is kind of an answer to that, which is basically like parse a program to a general parse tree that preserves some of the fundamental syntax that corresponds to tree structure, right? Which is typically like braces and parentheses and these things. But you also have to take into account things like comments and strings, because if you have parentheses or braces in a comment or in a string, you don't want that to be considered part of the tree or the syntax that you're trying to parse. So it's not just a question of, you're gonna detect a couple important characters. It's like you actually sort of have to parse the whole thing. But the good news is that notion generalizes over a lot of languages, right? Because at the end of the day, trees are useful in programs. It turns out like this is a useful representation that basically all programs use. So if we can kind of approximate that in some way, then it's easy to manipulate. Now, there are tons of tools out there, right, that go along this thinking, and I can name a lot off the top of my head nowadays. There's like Tree Sitter, there's all various kinds of
Code mod.
And so the way I see it is, there's a lot of tooling in this space that addresses parts of the problems and parts of the kind of design space of code transformation. And so it's a matter of picking the right tool for the job. And if that tool that doesn't exist, you kind of have to engineer it. So Comby is my response to engineering a tool for this like purpose fit role of manipulating syntax at a smallish scale, at the scale of simple lint checks or linter transformations, autofixes, this sort of thing. And at the end of the day, I needed that to do to integrate with a more sophisticated approach of program repair, or what others might call automated program fixing or automated bug fixing. So that's the context.
That makes sense. So just to lay out kind of the spectrum of like pattern matching and replacement like tools and syntaxes, I guess on the far end of the spectrum, there's like the full-on compiler-based, static analysis-based tools, like that Java library that you were mentioning that actually hook into Java C or whatever the compiler is, and they compile the code, they build up the AST, and then there's probably like in order to express your transformation, you probably have to express it in terms of like programmatic changes to the AST or something like that, right? Or maybe so that's like one end of the spectrum, and then on the other end of the spectrum, I would say like probably things like regular expressions or tools that make use of regular expressions. Do you think that's kind of like an accurate bookending of the spectrum?
I think that's a good way to look at it. To my mind, there are multiple kind of spectra, let's say. Okay. I think you can actually, the way I think of tooling, to categorize the this vast tooling landscape of things that match and change code, it's more of kind of like a 2D landscape where you have various axes, right? And so along these axes, you have data points. So the one that you point out is a very good one to think about in terms of expressivity, right? What is the set of transformations that I can express? So regular expressions is on one end of this, and you can map some of this notion of expressivity to a more formal way of thinking in terms of, Chomsky's hierarchy and that sort of thing. I don't think you have to go that far because we're at the end of the day talking about tools here.
Yeah.
And so the tools, correspond in some sense to Chomsky's hierarchy, but I found that trying to, fit tooling into that formal notion isn't very good because there's a lot of overlap and fuzziness.
Chomsky's hierarchy is like this hierarchy of like languages from like your regular languages all the way up to like Turing complete languages. Is that
right? It's a way to describe kind of distinct capabilities in computation, right? So
okay.
Something that is expressive at a context-free level kind of can recognize languages in a regular expression language and so on. So it's just a breakdown basically of at a formal level recognizing languages, but it corresponds to the ability to compute, right?
Yeah, makes sense.
And as far as tooling goes, regular expressions or regular expression tooling like grep, have certain operators that break out of the regular expression, the formal notion of regular expressions, right? So
yeah.
So in terms of what you were saying about the spectrum of tooling, there's this idea of expressivity, right? So regular expressions, and then compilers are at least able to recognize context-free constructs, which are things like balanced parentheses, but typically you need a context-sensitive notion to recognize things like type defs in C, for example. So this is like you need to know about things that were defined at the point that they were used in order to interpret or parse something correctly. So there are all these notions, and tools take that into account to varying degrees. If you use an actual compiler tool, it knows about all of these things, right? And so that's a useful way to think of it in terms of expressivity, and that translates into performance as well, right? Like regular expressions can be extremely fast, and compiling can be comparatively slow. So that's one way. The other way that I think of it is in terms of how you specify things, right? How you express what you can match. Or transform. And this is something where with Comby it was like, well, I want something simple and lightweight. I don't want to go and write a program or a script or a Clang plugin. This is just too much effort for what I'm trying to achieve. Similarly, with regular expressions, there are some great things about it, but it's a lot of people also gripe about the syntax, and so. There's a lot to take into account that is not about expressivity or performance. It's also how you describe what you're trying to do, and I think that's really where a lot of design choices and tooling choices come into play, as far as how important it is for a tool to succeed or be effective in the domain that it's intended for.
So Comby, if I understand correctly, what you're saying is that it's the syntax and this tool that kind of hits a sweet spot in this two-dimensional space. Like it's expressive enough that you can describe basically like 98% of what you want to do in like everyday kind of find and replace instances in code. But at the same time, it has this ease of use or like ergonomics, developer ergonomics aspect to it that makes it a lot easier to kind of write patterns in it than something like regex, which as far as I know, like every developer that uses regex has kind of a love-hate relationship.
Right. Yeah. I mean, the goal is definitely like to make it lightweight, to make it as declarative as possible. So, I've kind of made the choice of, not allowing meta syntax or escape characters or things like this, just as a usability thing. But over time, I've also come to recognize that, it's very useful in this world to match, lexical constructs, just things that regular expressions are good at, and why reinvent another language? So, that especially one that's so popular that people are already to some extent familiar with. So, you know, Comby is now kind of advancing to the state where you can optionally embed regular expression syntax into it to match those things. Things like certain character classes.
Yeah.
So there's definitely parts of syntax that you can improve on it, and certainly I've strived to make it declarative, so it's not so much dependent on writing a program or expressing exactly, oh, this is a function that I want to match, or this is a variable. None of that is really incorporated. It's all purely syntactic and purely reliant kind of on just coarse syntactic structures that certain languages have. So if you're in Erlang and you have certain keywords that delineate blocks, or Ruby, um, then it would recognize those things. So it's language specific at some level, but it's not at the kind of semantic level where you necessarily know that, oh, I want to match a function block. So basically, there's a way of identifying syntax that correspond to the underlying language construct that you might be interested in.
Yeah, it's kind of like it handles the balanced delimiter like patterns that are fairly common in code, like string quotes, parens, brackets, that sort of thing. It
Right.
handles those really well. Whereas like those are always super annoying to express in regex, because regular expressions have no concept of like memory, so that they can't keep track of like how many like nested layers deep you're into. Whereas like Comby kind of understands these at like a foundational level, and the syntax makes it easy to, because like I've tried it myself, and it's like if you want to switch the order of like arguments in a function call, for instance, it's just like I guess that maybe you could get to the notion of holes, but like, you express like these holes, which are just like in the syntax, it's just like colon, bracket, and then a number, and then that becomes an argument, and you can type it out. It looks like actual code, the pattern that you wrote, and then that's the pattern, and then you express the replacement pattern, just referencing the numbers that you entered into those like holes later, and it's super kind of intuitive, I think.
You can compare whole syntax. I mean, you could compare this just to named identifiers or named groups in regular expressions. People rarely end up, I think, in practice using named identifiers for regular expressions, because they're not used in the context of changing code, right? It's just, I just want to match this thing. Maybe I'll group some expressions, but I'm not going to attach a name to it. And I think that also limits like readability, right? Like if I wrote something and I'm going to match a group of something, maybe it corresponds to a telephone number, and give that to you, Byung, and I'm like, here's the regex. Maybe you don't even know that this like grouped expression corresponds to the numbers that I care about. So with Comby, it's kind of like you tend to explicitly match that identifier to the text that the whole like contextually corresponds to, and so you can reference that when you're rewriting the code, which is with your swap arguments example, it's like, okay, well, now you already have the identifiers that you can use to swap arguments 1 and 2. As you said, it's kind of this, it's a way to kind of identify and rewrite structural pieces of your code. So maybe you want to identify calls inside of a loop, or inside double for loops, nested for loops, and there are certain calls you want to match or check. So one example is you compile. It's funny. So you can find code, right, where you compile regular expressions, right? So you can use Comby, for example, to find where you're maybe compiling and recompiling a regular expression inside a loop, and that's redundant. Typically what you want to do is you want to compile the regular expression once outside of the loop if it doesn't change, if the loop doesn't affect the regular expression, and then just run that regular expression on whatever is inside the loop. So there are certainly cases like that I found in Java or Go or pick your language, right? This is an easy mistake to make. So that's kind of a very kind of concrete and accessible example of how you might use it, where regular expressions are just going to be hard to identify.
And we should mention to folks listening that Comby is not just a syntax. It's actually like a command line tool. And if you go to comby.dev, you can look up the documentation, like actually just download the tool. I think supports Mac OS, Linux, and I don't know if it's on Windows yet, but
Well,
you get to like
everything's on
download and use
Windows
it.
nowadays with Windows.
Oh yeah, the
Windows.
subsystem.
Yeah, that's the recommended way to go for
Cool.
sure. Yeah, and always happy to help out. Hopping at the Gitter channel or just
there's a
DM
Gitter
on
channel, and
Twitter.
you're super responsive on it. I noticed.
Yeah, it's a valuable way for me to also collect feedback and understand what people want to use the tool for.
What sort of people have reached out so far, and what sort of use cases have you kind of seen in the wild?
It's interesting. I think there's a wide array of things that people want to do once you tell them, hey, you can change your code in certain ways, and it can be more sophisticated than regular expressions. And I think what's interesting is that you end up with a lot of kind of interesting and unexpected ideas. So one example of just usage is people wanting a way to review code change by code change. So I want to go through these because they're not all going to match exactly the thing I'm interested in, or maybe it changes like some test code that I don't want to have affected. And so I think CodeMod, the Facebook variety of CodeMod, the actual tool on GitHub, kind of pioneered that idea, which is this iterative like review, patch, or code change. And that's something I integrated kind of after the fact, right? In response to
this is like the interactive.
Workflow. Yeah,
this is the interactive mode. So like you can go through and it'll actually show you each place that the pattern matched and ask you like, do you want to change this? Yes or no?
Yes, exactly. So
cool.
That was something that people wanted just to integrate into their workflow. What I've seen other people want to do is changing things inside of HTML tags, class attributes, names. This sort of thing crops up often.
Yeah.
And that's again another place where it's that kind of pointed out to me that to some extent you want to support regular expressions to let people like match their arbitrary kind of classes of characters, but within angle bracket tags or within strings, for example.
How much do you find yourself reaching for Comby and day-to-day pattern matching find replace tasks versus something like grep or sed or like define and replace in your editor?
It's an interesting question. Right now, I am most drawn to using Comby for kind of higher level applications rather than I want to change a couple of things in my code. I've done it a couple of times, working with SourceGraph, and so it's cropped up a couple of times where it's like, I want to change particularly things in tests. For example, you have like a bunch of test cases, and these test cases are very similar. Like maybe you have 20 or 30 or 40 test cases, and each of these test cases is like a record or a struct, and you have a field and a value, and maybe you want to rename those fields, or you want to rename, or you want to add something to the structs or whatever, and then it can be useful because then you can just match on that each independent struct and then add some field, and maybe it's dependent on some other input. So I recall a couple times needing that. Maybe I don't know, maybe once a week or once every couple of weeks I run into a case like that. So not super often, but I don't end up using sed for things much either. But the kind of appeal I see right now for using Comby is more in the sense of manipulating code for other purposes. So one is mutation testing. So for the unfamiliar, mutation testing is this idea of transforming your program and then running a test suite. And then if your test suite doesn't detect anything bad, you've essentially created a mutant program that if you've changed it in some way that you want it to fail but don't, then that's a gap in your test suite, right? And so you can imagine that easily changing programs in that scenario is very useful. There's a lot of research in that space, academic research, and a lot of tooling associated with that research as well. And usually it does come down to a more heavyweight tool, or maybe you're just like, hey, I'm just going to like focus on Java or C to evaluate some interesting new approach. And so with Comby, that could be something that you could do at the most general level, right? not restricted to any particular language as
Yeah.
far as the tooling goes.
I myself have tried to use some of those more kind of heavyweight refactoring tools that actually hook into the AST, and my experience is that this is quite a like learning curve, because you kind of have to like learn the ins and outs of the AST, and in order to ensure that you can actually like express the pattern that you're trying to describe. And it's almost there's a greater mental barrier, because like when I think about the pattern that I want to match, oftentimes it's like at a kind of textual or syntactic level, like, oh, switch these arguments, or, oh, add another argument to the end of this function, or, move this rename this struct field or something like that.
Mm-hmm.
And I'm not really thinking about like which AST node specifically I have to modify, and like at which kind of like layer in the tree that they might occur, and what are all the other like hidden AST nodes that I don't even know about, but are kind of like implicitly constructed when the language gets parsed.
Yeah, for sure. That's part of it, right? Like Clang has an excellent like query matching or way to match kind of C or C++ syntax with a query language. So, they recognize that, okay, visitors, writing a plugin or, that does a programmatic thing using a visitor interface, that's kind of heavyweight sometimes. So we're going to introduce this query language. But in order to use this query language, you have to be familiar with all of the grammar constructs to make sure that you're not, you're matching on this this specific thing in the C++ grammar that you're actually interested in. And many of the time you might not even know that, the L value for assignment corresponds to the left-hand side. It's very heavyweight. So as a what I would say a declarative technique allows you to do is kind of what you see is what you get, right? And that's kind of the aim here. Now, of course, there are many tools again out there that do declarative like transformation and matching, especially on the academic side. So you can find tools like Rascal, and Spoofax is like a language workbench that covers a lot of languages, and you can kind of define all of these declarative ways to match your syntax. But at the end of the day, you either have to like dig up the thing that you want, or kind of learn a little bit more context about those tools. And with Comby, it's this thing that basically I wanted it just to be, brew, install, and then run thing that I care about, and not pay too much attention to, is this like a fully fledged parser? Is this, did someone go and make the effort to turn this into a declarative way to specify things for Java or whatnot?
Yeah. I want to return to kind of an earlier use case. So like, we've talked a bit about how this can make the lives of people who are doing kind of like serious refactors easier. So like people who would use more of a heavyweight tool if Comby didn't exist. But I kind of want to return to that like everyday use case, the kind of like regex replacement use case. Because you said you don't use it every day. I actually find myself using it more and more often, and I do wonder whether, like, in my view, there's kind of this hurdle that like any new everyday tool has to overcome, which is kind of like the familiarity hurdle, right? Like the people who have already invested many hours of our lives into learning regex syntax and all its special variants.
Mm-hmm.
That's kind of like a thing that we already have, and now along comes like a new syntax, and it's like, oh, do I really want to learn this? A thing that I have, it's not perfect, but it works reasonably well. But I do wonder, because I know a lot of other programmers, both new and some fairly experienced, who actually have avoided regex so far. And it's like something that's kind of like scary to them. And I almost feel that like Comby would be in many ways like a better starting pattern matching syntax, because it's just more intuitive to use. You can kind of like parse it with your eyeballs. You don't have to go and like upload it to one of those like regex visualizers to figure out what the heck is going on. Do you think that Comby like will evolve into a tool like that, especially for beginners, where they kind of use it in more of an everyday setting?
I am very happy to see that happen, but it's not I wouldn't say that's kind of an end goal, at least to the extent of, I'm not pushing for the tool to be adopted by, let's say, novice or unfamiliar, programmers. It's more a question of, the tool is designed to do something in a simple way, something more complex than regex allows in a simpler way. And I think you can absolutely hone in on, how do I make it, minimally simple for people to do X, as far as matching or transforming code goes. And I think that would, at some point you're going to come up to, your tool's going to sacrifice something in the interest of simplicity. So the kind of thing that's top of mind for me in designing, syntax for Comby is make it dead easy to kind of, match code and make things correspond to code. But at the same time, there have been more and more kind of examples where, once you start using the tool, you want something more out of it. You want to maybe here's a concrete example, right? It's like, hey, I want to sort my list of imports in my program alphabetically, right?
Yeah.
And so Comby can make it super easy for you to like match all the import statements, within some like import group, parenthesized import group in Go, for example. But it doesn't have any native capability to go and say, okay, I have a list or a set of lines that were matched, and now I want to sort these less lexicographically, right? Like that capability doesn't exist, and you could pipe that stuff into another program and then rewrite, and that's something you could do. But the point kind of here is, at the end of the day, it's good at doing one thing really well, which is match, syntax that corresponds to code structures. And then whatever comes on top of that, I'd love to support things and branch out capabilities, but you have to kind of draw the line somewhere. And I think the same thing happens essentially when you say, hey, I want to make this thing super accessible, right, to people who don't know regular expressions. And I don't know what the shape of that solution looks like, but certainly some of the designs and decisions around the syntax of Comby, advocate for a solution like that.
Yeah, that makes sense. I want to kind of take a step back and like chat about some of the other research that you've done. But before we move on to that, I think it would be remiss of us if we were not to mention that the Comby syntax is actually supported in SourceGraph currently. So if folks want to try that out, you just go to sourcegraph.com, and in the search bar, it's kind of like the bracket icon. It's called structural search. And so if folks want to try that out, we'd love to hear feedback on that.
Yeah, and I'm looking to put out more examples of that as well. Go find interesting things. Try it out. Give us feedback, and the benefit is there that you don't even have to clone your repos. You just we have repos up there, and you can search. For example, some of the more popular GitHub repositories, Java, Go, Python, all these things. It works out of the box.
Yeah. Actually, just a quick question on that. Like in implementing that syntax for SourceGraph, did you have to do anything special to get it to scale?
Well, we're doing some fancy things, leveraging the fact that we have indexed a lot of source code already, and can look up in certain files whether a file at all contains strings that would match. So there are various kind of optimizations that I worked on and built in to kind of identify that sort of thing, right? And it's not any different than whipping out like rip grep and then finding files that you want to search and then piping that into Comby. But the benefit is on sourcegraph.com, of course, that we do trigram indexing, which is even faster than rip grep. So so that's why it works really well out of the box.
Cool. But so with respect to the other research that you've done, my understanding is that you wrote Comby because you were having trouble with like pattern matching and replacement because of another aspect of your research. Can you tell us about like that, I guess, initial motivating problem, and or maybe just like about your thesis in general and what were kind of the themes there?
Yeah, so my high level focus was to take existing tools that we have out there that are fairly popular and useful in practice, to find bugs, right? So to find bugs that are a little bit more sophisticated at a semantic level, right? So not your, oh, I'm missing a semicolon, or I have some lint check that's failing, but um, something more in the line of, oh, you forgot to close this file resource, and maybe you've opened a file or a socket and one function, and then three function calls deep, you're done with this thing, or you've returned up the stack and you forget to close it, right?
Mm-hmm.
So from a program analysis perspective, this gets pretty complex, because now you have to consider, calls across multiple functions, different contexts in which a function is called, whether any logic inside of, if conditionals or for loops change whether you close the file later or not, because you don't want false positive. You don't want the analyzer telling you, hey, you didn't close this file, but then you did, and the analyzer is too dumb to know the difference, right?
Yeah.
That's the flavor of maybe the sort of bug that you want to fix. And so I went and dove in and said, okay, given that an analysis ran, it knows things, it has reason that there's this bug that happened. How can we go about fixing that automatically? So we want to make some change to the program and fix this bug in a way that we can have a reasonable amount of confidence that it is fixed. And so there's kind of a lot of detail to that, and I won't necessarily go into all of it, but basically you leverage the fact that a static analysis, and so in this case I used a tool called Infer, which is also open source on GitHub, and that's maintained by Facebook, and I think it's a great tool to have out there, and it finds this sort of bug like resource leaks and memory leaks in C programs and so on. And so
yeah,
I was using that as like one tool as a basis of trying to automatically fix the bugs it reports. And so at the end of the day, you can use some of the things that the analysis inferred about your code to also inform a fix, right? You can, for example, identify places in the code that also close a file on some condition, and you can identify that in the analysis output. But once you have that, right, it's like, okay, I'm ready to make a change. I'm ready to change the program. And that means you have to make a syntactic change, right? Like at some level, this stuff has to translate back into a syntactic change to the program. Okay, so you're like, I'm ready for this. I just need to add this like close socket inside this if condition.
Yeah,
like, this is what I need to do. And it's like, okay, how can I match on the body of this if condition reliably, so I can just insert and this is kind of where I ran into this problem, which is like, okay, I know everything that I need to know what I want to do. It's just not easy to just do this one thing, right? Like I just gotta match this if conditions body inside these braces, but I can't, because there are too many parentheses in the if condition. There are too many braces inside that confuse regular expressions. Like I tried regular expressions at first. It's like, maybe I can get around this. Maybe I can just it's a research problem. This isn't like part of a novel or significant contribution. I just want to do this change, right? And so this is where I got.
You thought finding the issue would be the hard part, and then actually making the change would be easy, but it turns out making the change was a lot more annoying.
Yeah, absolutely. And so it became this kind of thorn in my side, right? And that it was at that point where I ended up using, I think, a specific Java thing at that point, but I came out of that thinking, this is ridiculous. I'm not doing that again, and this is actively hindering like other things I want to do in my research. So I'm going to go build this tool, and that's kind of how it sprung out. And it was kind of built around that purpose.
That motivating problem is really interesting, because like the kind of magical like the thing that I've used that's probably closest to that would be like find bugs in the Java world. But like when you get suggestions like that where it finds like actual bugs in your code and flags them to you, that is almost like the first time you see that, it's like a wow moment. You're like, wow, this is magical. It knows what's going on in the code.
Yeah.
And I think like these days you see more and more kind of stronger claims being made about what actually can be done. I think you and I have chatted at length about like machine learning, for instance, is a topic or buzzword that's thrown about a lot these days, and I've seen it used a number of times in the specific domain of like code transformations and automatically writing programs. Which admittedly, would take it a step beyond even just the like kind of semantic analysis and transformation. We've chatted about this at some length. I'd be curious if you could share your thoughts with the podcast audience about like the intersection of machine learning and language analysis and programming automation.
Yeah, I'll scope it a little bit more to say I'll only kind of comment on I think the interesting aspects around can we use, for example, machine learning to automatically generate or fix programs. I think I'm more familiar with the kind of effort around automatically trying to fix programs using, for example, machine learning. And I think there's also a distinction between applying machine learning in industry, scenarios versus academic, efforts around machine learning. So, to me, it's a matter of, well, there are many approaches that say, well, okay, programs are just data, and we're gonna feed it into some supervised learning algorithm. We're going to get some outputs, and we can use that, right, and show that the result is useful for some context. And you can absolutely do that for something like automated program repair or automated bug fixing. But I think the challenge here is that, like, if you treat it like a black box, right, the stuff you're going to get out is going to be kind of a function of the fidelity of things that you fit into it. And if you're just treating it as text, then there's only there's an extent to how good you can do when you get the outputs. And so despite the tendency to just throw things at a machine learning algorithm, which happens, right, in research, and I think it's not totally unreasonable to report on those results and say, hey, we've observed this and it's sort of useful, maybe. We're not really sure, right? But I think it's important to caveat that and say, well, programs are a lot more structured. That's why they're so interesting, and we have a wealth of history on program analysis and research that really dives into what's the complexity, what's the underlying complexity of the thing we're dealing with, this problem that we're trying to solve. And I mean, it's already been proven at a formal level that any sufficiently interesting property is impossible to detect in general, right? And so this corresponds to Rice's theorem, and if you're interested in that, you can go dive into that. But the point is, like, neither machine learning nor anything else can actually solve this at a very general level, but we can do pretty dang good if we reason about what we can and cannot do in certain contexts, right? And what approximations we're going to make. And so I think machine learning as a tool to solve a problem is very coarse, unless you encode all of the stuff that we know. And so one of these things that we know about programs is they have structure, they have grammar, they have various attributes and semantics around certain buggy properties. And so I think kind of the research space is split between those two lines of thought, right? It's like, do we come from the perspective of, okay, we're treating this as a program, as with a foundation that's logical or able to reason about and model, maybe in a discrete sense, versus, okay, we have a very powerful kind of inference engine, but it is based on kind of elements that we're not going to reason about or necessarily incorporate, or explain how we arrived at a certain result. And so my hope is, these two things converge and get closer to each other. They're a bit detached, and so of these two camps, I fall very much into the study and research programs as a structured or logical concept, and then maybe on top of that, implement various ways to do something like machine learning or other AI approaches to kind of reveal interesting properties or ways of fixing programs, right?
Yeah. Are there any efforts, either in industry or academia, that you're aware of that, in your view, are taking kind of the right approach of synthesizing these two worlds?
I don't know so much about synthesis. I think
Okay.
I don't know of any good examples right now, at least that I can point to. I will say that in terms of where we are going with automated reasoning and things like being able to generate programs automatically or fix programs automatically, are we going to put software developers out of jobs, or are they going to at some point we're not going to need certain types of software developers or engineers. In terms of that, I think it's clear that we're not quite, and I don't see us getting there anytime soon. Automating away any substantive engineering ability. What we are doing is getting closer to kind of removing the tedium around certain bug fixes and reasoning about certain pieces of code, and also just engineering oversight. So it's like you're coding, you're just trying to implement some new interface to call out some other code that to or removing a feature flag or something like this. And then bugs crop up, and it's like, I don't want to deal with this right now, or you maybe not thinking about that right now, or it's not in your mind right now. And then an analysis tool picks that up, right? And that's really where the value is, and that's really the gap I see, kind of the tooling and automated nature of software analysis going, is really to make us more effective at working on the core of the problem, right? And the core of our day jobs. We don't want to deal with all the tedium and the do I have to check this thing whether it's null again?
Yeah, the knowing parts of the job. We want to focus
Exactly.
on the creative and fun parts.
Yeah. So as far as successful efforts in industry, I think since I was at Facebook and I kind of follow along the research that's adjacent to some of their stuff. I think they're really doing well at doing kind of automated program repair or automated bug fixing for these more sophisticated classes of bugs that I mentioned. And so they're looking at things like null dereferences, for Java and so on, and automatically fixing them, incorporating that into their CI. And you can go look up on the internet. There's a project called Sapienz, so Mark Harmon and his team behind that. They do some pretty interesting stuff where it's really like kind of at this frontier of, okay, we're at the point where we can kind of change programs and they result in kind of mostly reliable, or at least feasible fixes to bugs that we are willing to show to developers and say, hey, does this fix your issue? And it becomes this kind of push button approach to automating these fixes. And that's really what I also kind of went after in my research. It's like, can we achieve this idea of like push button program repair, where we have enough confidence about a bug fix that we're willing to show it to developers and say, hey, we actually tested this, right? Like this fix stops this test from failing, or this fix stops this analysis from reporting a bug, and we have high confidence that this is an actual issue. And so I'm excited to kind of see that expand, and I think it's a question of when. It's going to happen eventually, where we see more of this sort of tooling kind of crop up. And it's very much going to be, I think, a function of integrating with a developer's workflow, whether that's CI or in their editor, or a tool that they use to search or review code. That's really going to be the interface to this sort of interaction, where you interact with an automated tool and what it did. There's going to have to be a human in the loop for a lot of it, and I see that factoring into especially things like your CI workflow and editors.
Yeah. You mentioned that you worked at Facebook for a bit. I believe you also did stints at MSR and Google, if I'm not mistaken. Of those three companies, we only have a short time left, but like, are there any like projects that you think are worth calling out there that were particularly interesting to you in the space of developer tools?
Yeah, so my focus became more specialized, I think, as I did more of these internships, right? So I think the most recent and most kind of focused to my interests and speciality was at Facebook, right? So I worked on, Pyre, which is a static type checker for Python, and it's really interesting to me that over time Facebook has kind of gone and been very, very much investing in tooling, right? For software quality, things like bug detection, type checking for Python, and this sort of thing. And my impression is, Facebook is kind of at the forefront of doing this. Google, Microsoft, for sure, they invest in their tooling, and a lot of it's great. But I think a lot of talented researchers and engineers are working on these tools that have really impressive results. So finding anything from super sophisticated bugs in Hack that could lead to Facebook servers being compromised, or just daily developer I missed this nullity reference check. They've really kind of covered a broad space of it. I think Amazon is also now ramping up a lot of their dev tools and program analysis efforts. But certainly it's been interesting to see Facebook as a social media company at the end of the day really investing so heavily into software quality dev tools. And so that to me just says, this is if it isn't already, it will be a ubiquitous concern for any software company, right? As you grow, as you understand the complexity of what you're doing and what your software and the activities that your engineers are engaged in, it becomes a critical piece that has to integrate with what you're doing. And if you're a company that isn't aware of that yet, right, it's a bit of a blind spot. I think this problem becomes more important as you grow, obviously, like the size of your company matters, right? And so that's really where the value of these automated tools like automated bug fixes, automated bug finding come into play, is as soon as you reach a scale where you want to cover a lot of ground and a lot of the complexity of millions, billions of lines of code.
If folks listening want to learn more about Comby or any of the research that you've done, how would you recommend they go about doing that?
The easiest way is probably to just find me on Twitter or just DM me on Twitter, and then we can fire off an email exchange if that's something that you're open to or you want to chat more in depth. So you can find me on Twitter at RVTond, RVTE. I'll redo that, at RVTOND.
Cool, and we'll put that in the show notes as well.
Sure.
My guest today has been Renard Van Tonder. Renard, thanks for being on the show.
Thanks, Biang.
The SourceGraph podcast is a production of SourceGraph, the universal code search engine, which gives you fast and expressive search over the world of code you care about. SourceGraph also provides code navigation abilities like jump to def and references in code review, and integrates seamlessly with your code host, whether you're working in open source or on a big, hairy enterprise codebase. To learn more, visit sourcegraph.com. See you next time.